A very good morning. I am Srinivasa Reddy, Associate Professor of Mathematics, Government College Round. Today, we talk on a non-homogeneous linear differential equation with constant coefficients. How to solve non-homogeneous linear differential equation, constant coefficients. Last class we have seen how to solve homogeneous linear differential equation with constant coefficients. So, today we see how to solve PD of y is equal to qx, the non-homogeneous linear differential equation. PD of y equal to qx with constant coefficients. How to solve? First step one. First, find out the general solution of the equation one. General solution of the homogeneous equation one. That means, if qx equals 0, then the given equation is called it is called linear. It's called a homogeneous linear differential equation with constant coefficient. First, find out the general solution of the homogeneous equation of one. That is a PD of y equal to 0. Homogeneous means right hand side qx equals 0. Then the equation PD y qx equals 0. PD y equals 0 is called a homogeneous equation. First, to find out the solution for this equation. This solution is called a complementary function. Simply we write CF. CF means complementary function of 1. And it is denoted by YC. So complementary function is denoted by YC. So how can we find YC? The solution of the homogeneous equation of 1. Homogeneous linear equation of 1. That is PDY. The solution of PD of y equals 0. We know that how to solve. Last class we have seen how to solve a linear differential equation. Linear differential equation of homogeneous. How to solve? We have seen homogeneous linear differential equation, and then the particular integral or a particular solution of PD of y qx is denoted by yp. So pi, particular integral or a particular solution of PD of y qx is denoted by yp, and it is defined by yp is equal to 1 by pd qx. So yp is defined by 1 by pd qx, and general solution of given equation 1 is y is equal to yc plus y. That is a y equal to complementary function plus particular. So we can yc can be find the yc can be find the solution of the PD of y equals 0, and pi means yp particular integral, that is 1 by pd qx. And also you can use these formulas for to find the yp sometimes. 1 by d minus alpha qx equal to integral e power alpha x qx dx, and second one 1 by d plus alpha qx equal to e power minus x qx dx. So how to find already we know that how we can find YC. Already we have seen last class how to find the solution of the homogeneous linear differential equation. So from the last by the last class we know how to find a complementary function. Now we have to see how to find yp when qx equal to b into e power ax, where ab are constants. So, for example, if qx equal to b equal x, first write in place of b equal a. If p of a not equal to 0, then yp is equal to simply 1 by pd qx. That is right, 1 by pd b equal x, just 1 by pa b equal x. Just write in place of b equal a and p of a not equal to 0. So, case 1, if p of a not equal to 0, then yp is equal to 1 by pd qx. That is 1 by pd b equal x. That is 1 by pa. 1 by pa b. For example, you see 1 yp equal 1 by d square minus 1 e power x. Here a is equal to 2. Here a is equal to substitute 2. It is not 0. So answer will be e power x. So what happens if p of a equals 0? So when we are substituting d equal a, if p of a equals 0, then d minus a is factor of p. We know that if f of a equals 0, then x minus a is a factor of fx. So here if p of a equals 0, then d minus is a factor of pd. Suppose d minus a whole power n is the factor of pd. Then and pd equal to suppose d minus a whole power n phi d, where phi of a not equal to 0. So then yp is equal to 1 by pd b e power x. B is constant. You can write d minus a whole power n 5d e power x. Here, writing here d in place of 5d. In 5d, writing d equal a, it is not 0, 5a. So the root will come n times. So factor d minus a comes to n times. So for this, x power n by n factorial and of x power n by n factorial 5a e power x. So suppose PD is d minus a whole power 5d, where phi of a not equal to 0. Then what is the yp particular integral? Just b x power n by n factorial phi of a e power x. For example, simple example. So yp is equal to 1 by d minus 1 whole square into d plus 3, d square plus 3 e power x. So here it is a 2 times. D minus 1 comes 2 times. So x square by 2 factor. Here right in place of d equal a means 1. So 1 plus 3. So x square by 8, 4 into 8 e power x. Another example, 1 by d minus 2 power n d square plus 3d plus 2 e power x. Write that d is equal to x e power to x by, here d minus 2 is a power 1, so x by 1 factorial. So write the a in place of a here, it is not 0. 2 square plus 3 into 2 plus 2, that is 4 plus 6 plus 2, that is 12, x e power to x by 12. So when we are to find the yp when qx equal to e power x, it is very easy. Suppose if p of a not equal to 0, then directly answer will be 1 by pa b into e power x. If p of a equals 0, then d minus a is the factor of pd. And suppose p of d equal d minus a whole power n phi d phi of a not equal to 0, then what is the yp? Just it is d minus a factor will come n times, so x power n by n factorial and phi of a e power ax. See some problems on this. For example, you see for example, let's say d square minus 2d plus 5 of y equal to e power x. So this is like comparing with the pd of y equal to qx. What is pd here? D square minus 2d plus 5. Qx is e power minus 6. So first, to find yc, first find out the auxiliary equation, roots of auxiliary equation. What is the auxiliary equation? So here auxiliary equation is Pm equals 0. That is a m square minus 2m plus 5 equals 0. So m is equal. We know that the roots of quadratic equation ax square plus bx plus c equals 0. X equal to minus b plus or minus root of b square minus 4ac by 2a. Here a is 1. Comparing with, in place of x, y m is there. A is 1. B is minus 2. C is 5. So what is m? Minus b. Already b means minus 2 minus of minus 2 plus 2 plus or minus root of b square. Minus 2 whole square is 4. Minus 4a is 4 into 1 into 5. 20. So 2 plus or minus root of 4 minus 20 by 2. That is 2 plus or minus minus 16. That is so minus 16 means 16 I square, that is 4. So we know that I square equal to minus 1. So 2 will be cancelled. 1 plus or minus. So these are the complex roots. We know that for the complex roots, what is the solution? E power ax c1 cos bx plus c2 sin bx. Here in place of a1, in place of b1. So comparing with the a plus r minus ib, a plus r minus ib, we can, here a is 1, b is 1. For e power x c1 cos bx plus c2 sin bx. So for e power x c1 cos bx plus c2 sin bx. So what is the particular integral yp? That is 1 by pd qx. that is 1 by d square minus 2d plus 5 e power x. Comparing with the e power ax equal to e power x, write d equal to a. In place of a here, e power x 1. So 1x, x means 1x, that is d equal to 1. Substitute 1. So it's not 0. So 1 minus 2 plus 5. It's 1 by 4. Here p of a not equal to p of 1 not equal to 0. So therefore 1 minus 2 substituting d is equal to 1. 1 square 1 minus 2 into 1 minus 2 plus 5. That is 1 by 4 e power x. The general solution is y equal to yc plus 5. The solution is y equal to e power x c1 cos x plus c2 sin x plus 1 by 4 e power x. The next problem, see. So solve y double dash minus y dash minus 2y equal to e power x. You know that y double dash means d square by dx square. This is minus dy by dx minus 2y that equal to e power x. So d is equal to d by dx, then this can be written as d square minus 3 minus 2 of y equal to e power x. So where pd equal to d square minus 3 minus 2, 2x equal to e power x. So what is the auxiliary equation? Your auxiliary equation is a pm equal to 0. Auxiliary equation is a pm equal to 0. M square minus m minus 2 equal to 0. This can be written as m minus 2 into m plus 1, because here minus 2 into 1. So 1 into minus 2. So here we see m square minus 2m plus m. So this can be written as m square m minus 2 into m plus 1. So we are getting roots 2 comma minus 1. That is yc equal to different roots, real roots and different. So yc equal to c1 e power 2x plus c2 e power minus. So yp is a 1 by pd qx e power x. So here equal comparing with e, but write d equal a is 1 e power x means a is 1, right? 1 d in place of d, 1 square 1 1 minus 1 minus 2, that is e power x minus 2. General solution to y equal to yc plus yp. The solution is y is equal to c1 e power 2x plus c2 e power minus x minus e power x. Right? Let's see another problem. So can solve d square plus 4d plus 4 of y is equal to e power 2x minus e power minus 2. Comparing with the pd of y, pd of y equal to qx, where pd is equal to d square plus 4d plus 4. So qx equal to e power 2x minus e power minus 2. So what is here? Auxiliary equation is to find first yc. We have to find the roots of the auxiliary equation. So how can we find? So auxiliary equation is pm equals 0, m square plus 4m plus 4 equals 0. This is like a square plus 2ab plus b square. So a plus b whole square, that is m plus 2 whole square equals 0. what are the roots? M is equal to -2, -2. Here roots are repeated. So -2 repeated twice. The solution is we know that yc equal to c1 plus c2x plus e power -2x. Because here the root -2 repeated twice. So yc equal to c1 plus c2x into e power -2x. So what is the yp? Yp means 1 by p dqx, that is 1 by d square plus 4d plus 4. 1 by d square plus 4d plus 4 e power 2x minus e power minus 2x. So 1 plus d plus 2 whole square e power 2x minus 1 by d plus 2 whole square e power minus 2x. So writing here, right, in place of d equal a means here 2, equal to 2 here. So 2 plus 2 whole square. So 1 by 2 plus 2 whole square, that is e power 2x, that is e power 2x by 4, 2x by 4. So here p of a not equal to 0, that's why here write d equal to. But here p of a equal to 0, writing d equal to minus 2 is 0. We know that 1 by d minus a whole power n equal to e power a is equal to x power n by n factorial e power x. So here a is equal to minus 2. So d plus 2, this factor comes 2 times, so x square by 2 factor. So if suppose 1 by d minus a whole power n e power x equal x power n by n factorial e power x. Here x square by 2 factorial e power minus 2x. Here a is the minus 2. Finally, we are getting e power 2x by, this is 16. See, e power 2x by 16 minus x square by 2 e power minus 2. Here e power 2x by 16. So finally, how to solve PD of y equal to qx with the constant coefficients? First, we have to find out the yc. To find yc, how can we find yc? First, write auxiliary equation. So like this here, pm equal to 0. And find out the roots of the equation. So using this, write the solution of the homogeneous differential equation PD of y equal to 0. So after finding roots, write the complementary function yc. So here -2 -2, it is repeated twice. That's why c1 plus c2x e power minus 2x. And then yp is equal to 1 by p dqx. So 1 by d square plus 4d plus 4 of e power 2x, e power 2x minus e power minus 2x. That is 1 by d plus 2 whole square e power 2x. So if p of a not equal to 0, then 1 by pa e power x. Here d equal to 2 plus 2 whole square 16. Have to get here 16. And here they write in d equal to minus 2, we are getting 0, p of a equal to 0. Then here d plus 2 is a factor. Suppose 1 by d minus a whole power n equal x power n by n factorial e power x, therefore a is equal to minus 2. So d plus 2 factor comes 2 times, so x square by 2 factorial e power minus 2x. Well, you can do this problem. For example, t square plus 60 plus 9 of y equal to 2 e power minus 3x, 2 e power minus 6. Writing auxiliary equation, we'll get m plus m square plus 6m plus 9 equal to 0. That is m plus 3 whole square equal to 0. So m is equal to minus 3 minus like this. Here you get this minus 3 minus 3. Writing y is equal to c1 plus c2x e power minus 2x. And yp is what is the yp? 1 by pd qx. So writing this here 1 by d plus 3 whole square 2 e power minus 3x, will get x square by 2 factorial e power minus 3x. Okay. Finally, how to solve a non-homogeneous linear differential equation with the constant coefficients. So how to find non-homogeneous solution of the non-homogeneous linear differential equation with constant coefficients? So first to find the general solution of homogeneous equation of form, that is the PD of y equals 0. First find out the solution of the PD of y equals 0. This solution is called complementary function of 1 and it is denoted by YC. So YC means complementary function, means we will get complementary function finding the solution of the homogeneous equation of the given equation, that is PD of y equals 0. The solution of PD of y equals 0 is called complementary function and it is denoted by YC. YC means complementary function. And how can we find particular integral Pi or solution of PD of y, the particular solution of PD of PD of y equals Qx divided by Yp, and Yp equal 1 by PD Qx. So the general solution of given equation 1 is the y is equal to Yc plus Yp. That is y equal to complementary function plus particular integral. So finally, how to find PD of y equal to Q, PD of y equal to Qx. First, find out the solution of the homogeneous differential equation of 1. That means solution of PD of y equal 0, that is called complementary function, that is Yc. And the Yp will be can be find Yp is equal to 1 by PD Qx. So finally, solution is y equal to Yc plus 1. Today we have seen how to solve PD of Qx when Qx equal to e power Ax.